So, light misconception three is that the moon is a source of light. So, early on in elementary school, students learn that objects such as a lamp, a fire, or the sun create their own light and are called sources. However, some children overgeneralize and can end up thinking a light source is anything that's bright or shines, such as a mirror, a glass window, a bicycle reflector, or the moon. Of course, these objects are not sources because they do not generate their own light. And if no source were available to illuminate them, they would not be visible. They're instead good reflectors of light. Um, the easiest way to reconstruct this is to ask the class just to investigate whether objects are light sources or not by looking at them while the room is in darkness. Sources will appear brighter than they do in a normally lit room, and non sources are going to be darker. A good way to elicit the misconception is to hold up a piece of reflective clothing in a dark room and shine a bright torch onto it. And the reflective areas will grow very brightly. And ask children whether or not the clothing is a source of light. The other thing, and this may not necessarily happen in kindergarten per se, but you can show children pictures of the phases of the moon to help address the misconception. Since if the moon were a light source, like the sun, the parts of it would never be in the shadow. The next misconception I want to address is that light does not travel in a straight line when it bounces off a mirror. We all know that if you ask anyone, what do you know about light scientifically, they will probably tell you that light always travels in a straight line. This helps explain phenomena such as shadows and reflections and the dispersion of light to produce a spectrum. Um, this misconception statement is correct in a sense that light travels towards the mirror, hits the surface, and then bounces away from the mirror in a different direction. And this is the reason why we're able to see our face in the mirror. However, throughout that journey, the light rays are traveling in perfectly straight lines. Um, Even though the mirror has changed the direction that the light was traveling in during each stage of its journey, the light still travels in perfectly straight lines. And like a mirror, a lens does not change a light's ray's path, but in between each change of direction, the light ray travels in straight lines. Now, something that does not help the situation is the fact that we commonly use the term bending light when we describe or talk about refraction, of course, not in kindergarten, implying that light does not always have a straight path when indeed it does. Now, this is not a misconception that will be fixed in kindergarten, but I did just want to introduce you to the fact that this misconception does exist, and just little things we can do in kindergarten to is just to make sure we, like, if we're drawing sun rays, that we draw them in straight lines and not squiggly lines just because it's cuter. um, and just things of that nature. Whenever we're talking about light or drawing light or illustrating light, we try our best that if we're trying to show the beams of light, that we make those beams straight. All right, the last misconception about light that we're going to talk about today is that my shadow is always there inside me and bright light can push it out. Um, if you taught kindergarten for any length of time, I'm sure you probably heard something to that effect. That where and they ask, where do shadows come from, and you say, well, they come from like the sun, like shining, and of course they're like, no, my shadow's inside me. Um, and this is one misconception that we have to definitely address. They might even think that because a shadow belongs to an object, the shape of the shadow is always a perfect replica of the object itself. Um, so I want to start by talking about the three categories that light can pass or be transmitted through. The first is transparent, meaning nearly all light can pass through it. Translucent, which allows only the passage of some light. And then we have opaque, which does not allow any light to be transmitted. So, because opaque objects block light completely, there's an area behind the object where no light is present. And this area does not contain light, so it appears black to us, and that is a shadow. Now, translucent objects can cast shadows, but because they allow some light to be transmitted, the shadows are a little hazy with no sharply defined edges, and they can never really be completely black. Um, so, shadows are covered in kindergarten, and one thing that children are required to understand is that shadows are created when a light source is blocked. And they also need to carry out experiments to investigate which factors can change the size, the sharpness, etc., of shadows. And now that we have gotten to this part, um, I will skip ahead. Normally, I would go to and show you the unit plan, but the lesson that I wanted to highlight from this unit plan, it's in about day 15 or 16, is a shadow puppet engineering design challenge. Um, and it goes really good with this fifth misconception that I just brought up. And if you just take a look here, we look at the learning targets that it addresses that demonstrate that light travels through some objects and is blocked by others, demonstrate how light creates shadows, demonstrate that objects can only be seen when a light source is present, and compare the effects of different amounts of light on the appearance of an object. So they go through this. You show a video on shadow puppets. Um, and then they have an engineering design challenge that they have to plan out, and then you actually get to have an actual a shadow puppet play. This here is just a slimmed down version when it comes up, a slimmed down version of the engineering design process that we use to kind of just simplify things for everyone. So this is going to be used throughout all of elementary, the simplified engineering design process. So if you see something in the art about an engineering design challenge, it's likely that it will be this simplified model. There's many models of the engineering design challenge that you can find, but this one was created in house by one of our curriculum specialists, and it's just as a way to have some consistency across the board. So that's all for light. We're going to be moving on to sound next.